A limit is basically like watching a 100-meter race. You know the runners are heading for the finish line, even if some never make it. Same with maths. A limit shows where the values are going, even if they don't actually get there. On a graph, limits are easy. That little arrow under the limit, it shows where we're headed on the x-axis, like our finish line. When you see lim, it's basically asking, what y value is the graph trying to hit as we get closer to a specific x value? In this case, it's 2, because as we sneak up to 3 on the x-axis, the y value is heading for 2. Now, this is super important. For a limit to actually exist, the graph has to head towards the exact same y value from both the left and the right sides. This important rule can be written like this. Look closely. You'll see little plus and minus signs next to the limit approach. That's called one-sided limits, and it's all about the direction we're heading towards the finish line. If there's a little plus, it means we're coming in from the right-hand side of the graph, moving left. If there's a little minus, it means we're approaching from the left-hand side, moving right. For the limit to exist, both sides have to head toward the same y value. In other words, we need to approach the same spot from both directions. Let's check out the next example. In question 1, we can see there's a small plus sign next to the limit approach, which means it's a one-sided limit. So we only care about what's happening from one side. The plus means we're moving along the graph from the right-hand side towards the left, and we're checking what y value the graph is aiming for as we get closer to 2 from the right. We can see the answer will be -1. In this question, we can also see it's a one-sided limit because there's that little minus sign next to the limit approach. The minus means we're moving along the graph from left to right, heading towards 2 on the x-axis. As we move from the left to the right, we can see the graph is aiming for a y value of -4. So our answer for this one-sided limit is -4. In the third question, we can see there's no little plus or minus next to the limit approach, which means this is a full limit, not a one-sided limit. This means that for the limit to actually exist at a certain point on the x-axis, the graph has to aim for the same y value from both the left and the right side. In our previous 2 questions, we saw that when we approached an x value of 2 from the right-hand side, the graph aimed for a y value of -1. But when we came from the left-hand side, it aimed for -4. Since the graph doesn't approach the same y value from both sides, the limit does not exist. In the last question, we can see it's not asking for a limit. It's just asking what is f of 2, meaning what is the actual y value where x equals 2. Now, if we look at the graph, we'll see there are 3 little dots at x equals 2. 2 of them are open circles, and 1 is filled in. The actual y value of the function is where the dot is filled in. So f of 2 will be -2. Winging calculus is like winging a parachute jump, fun until the ground shows up. Ditch the 30 open YouTube tabs at 2 a.m. trying to integrate and grab my ebook course, step-by-step fixes and shortcuts. Cheaper than your monthly coffee bill and way easier than explaining a flatlining GPA. Course link in the description. If this helped, smash like and subscribe. See you next time. Cheers!